All right, well, hey, everybody. We are in Tennessee Reveal Geometry, Lesson 7-6 on trapezoids and kites. All right, first off, let me say, yeah, these are quadrilaterals, but they are not in the parallelogram family. And the reason why is because their opposite sides are, both sets are not parallel. In the trapezoid, you've got one set of parallel sides. And in the kite, you do not have any parallel sides at all. But you do have a couple of congruent sides, two sets, in fact, in the kite. So yeah, they're interesting. They're an interesting quad. All right, so let's get into this. I'm on page 445 in your consumable workbook. Looks like we got quite a few definitions to go through. Trapezoid, basis of trapezoid, legs of trapezoid, all that good stuff. All right, so for you visual people, here we are. This is a trapezoid. You have one set of opposite sides that are parallel. Don't forget that's what these little filled-in triangles mean, parallel. So these are your base. The other two sides that are not parallel, they call those the legs. Now, if those two legs are equal to each other, it's an isosceles trapezoid. So an isosceles means you got two sides that are equal. All right, so you got two bases that are parallel. You got two other legs that are not parallel, and if those are congruent, it's called an isosceles trapezoid. All right, let's see. Oh, we're going to get into mid-segment. Okay, well, you don't have a mid-segment here in this particular figure, so I'm sure they're going to give us one, but if you take the middle of one leg, AD, and you connect it to the middle point of the other leg, BC, you've got what's called a mid-segment. All right, and then we'll get into kites later. All right, so we got here. All right. All right, example number 1 looks to be a proof. So it looks like you would just probably set these equal to each other. This is isosceles trapezoid. So you would set AD, which is the 4x plus 5, equal to BC, which is the 5x minus 6. Then you would just solve that. So I'm going to let you guys do that. We don't do proofs anymore, so thank goodness. All right, well, looks like you're going to have to plug in. Yeah, definitely plug in for the perimeter and whatnot. All right, so I'm going to go on to example number 2. Let's save some time. All right, so let's see. We got isosceles trapezoid in coordinate geometry. So I'm going to go on to page 447. And I think I'm going to pull up GeoGebra because they do the part of the problem for me, doing the slope. And it looks like they did the distance for me. So I'm just going to do it for my visual people in GeoGebra. All right, here we go. Pull this up. How big do I need it? All right, I need a -8, -4. I need a 0, 8. So I need to pull this down a little bit to get up to the 8. I need a 6, 8. So I'm good there. And I need a -6, -10. Ooh. All right, well, I'm going to have to pull this out quite a bit. This is going to be a pretty big trapezoid. Interesting. -6, -10. Let's see if I can do it this way. All right, so I'm going to go to my polygon. All right, here we go. -8, -4. R is 0, 8. S is 6, 8. And T is -6, -10. All right, interesting looking trapezoid here. Okay, show that QRST is a trapezoid and determine whether QRST is an isosceles trapezoid. Okay, well, to be a trapezoid, I have to have a set of parallel sides, and it looks like that's going to be AB and DC, so let's test that. Going to go over to where the angle is. And instead of clicking on angle, I'm going to click on slope because I want to know if those slopes are the same. Slopes of lines that are the same are parallel. So AB has a slope of 1.5. DC has a slope of 1.5. So yes, these are parallel to each other. AD is a -3. BC is a 0. These are not parallel. All right, so this is, in fact, a trapezoid. And you can see that by doing the slopes here. So yeah, it's a trapezoid. You've got a set of parallel sides, and the legs are not parallel. All right, so now we want to compare the lengths of those legs to see if it's an isosceles trapezoid. And you can see right here, they are not the same. So it's not an isosceles trapezoid. But if you're a visual learner, you might want to look at this. All right, same icon, the one we use the slope with, but this time you're going to click on distance and length. The length of the first leg is 6. The length of the other leg is not 6. It is 6.32. So if you're a teacher, your students might say, hey, they're the same, but because they're both 6. But 6 and 6.32 are not the same. We do not round this to 6 to say, hey, they're equal. So no, it's not an isosceles trapezoid. Not the same answer. So it's not a no. All right, so it looks like that's it for this page. And okay, it's it for example number 2. At the bottom of page 447 on your workbook, they get into mid-segment of a trapezoid. And I said it earlier, but for my visual people may not have understood. PQ is a base. TS is a base because those are your parallel sides. PT is a leg. QS is a leg because those are not your parallel sides. If you connect the midpoint of one leg, PT, to the midpoint of the other leg, QS, you get what is called a mid-segment. And there is a lot like a formula. Some teachers may call it an average of the two bases. However you want to look at it, it's the same thing. You're going to take base 1, which is PQ, 11, add it to base 2, which is TS, and that's 18, and divide by 2 to find the middle. If you remember midpoint from Unit 1 in the Tennessee Revealed Geometry, we were doing coordinates where you add them up and divide by 2. Add your 2x's, divide by 2. Add your 2y's, divide by 2. Same concept. You're going to add your 2 bases and divide by 2. And that's what example number 3 is doing. On the next page, page 448, is they are finding the average of these 2 bases. So UR is the average of PQ, which is 11, plus TS, which is 18. So what you want to do is add 11 plus 18 in your calculator or in your head, divide by 2, and you're going to get 14.5. And if you're a teacher and your students are like, can I get a decimal? Well, yeah, you can definitely get a decimal on this because 11 plus 18 is an odd number 29. So when you take an odd number and divide by 2, you're not going to get a straight up nice number. You're going to get a decimal. All right, so there's your answer. 14.5 is the distance from U to R. That's called a mid-segment. All right, looks like example number 4 is doing the same thing, except they give us the mid-segment. Well, that's okay. We're going to pretty much do something similar. All right, so Rn, which is 24, equals 1/2 of Lm, which is x plus QP, and that is 16.7. 16.7. All right, so 24 equals x plus 16.7. All right, we're going to, okay, where did the half go? Okay, so it looks like they actually want me to multiply 2 to the other side, so I apologize. It's not going to be 24. The opposite of dividing by 2 is to multiply by 2 will be 48 equals x plus 16.7. All right, so now we're going to subtract 16.7 to the other side. So take your 48, subtract 16.7, and you're going to end up with the length of LM, and LM is 31.3. So again, you're going to get a decimal, ladies and gentlemen. 31.3 is the length from L to M, and that is your base. And if you want to check this, a good way to check it is to add 31.3 plus the 16.7 and divide by 2. If you get 24, you did it right. If you do not get 24, something's not right. You did something wrong. So maybe you made a silly mistake. Maybe you set the problem up correctly or incorrectly, but you need to figure it out. All right. Okay, example number 5. We are at the bottom of page 448. All right, see what we got here. Got a trapezoid. AD is parallel to BC. Remember that weird looking skinny 11 symbol means parallel. Find the endpoints of the midsegment. Okay. All right. So a midsegment has to be the middle of your legs. AB is your leg. So I'm looking for the middle of AB. DC is your leg. So I'm looking for the middle of DC. And you'll notice they bring out that midpoint formula that I just spoke about. Add up your x's, divide by 2. Add up your y's, divide by 2. And if you were wondering what I meant by that, all right, here it is. AB, you're going to add 0, which is an x, and 18, which is an x, and divide by 2. Add the 8, which is a y, to the other 8, which is a y, divide by 2. Well, 0 plus 18 is 18, divided by 2 is 9. 8 plus 8 is 16. 16 divided by 2 is 8. So it looks like the midpoint would be 9, 8. Could be right about there. Okay, same thing on DC. If you're eyeballing it, I'm sure it's going to be somewhere like right in there, but let's do this. All right, 1 plus 20, because those are your x's, is 21. 21 divided by 2 is 10.5. 4 plus 0, which are your y's, add together. 4 plus 0 is 4, divided by 2 is 2. So you're going to have 9, 8, and 10.52. So like I said, somewhere, I knew it's somewhere in there. So we were a little off eyeballing it right there. 10.5 and then up to, so somewhere like right in there. Okay, let's go to the next page. All right, here are our kites. All right, so a kite is a quadrilateral, but it's very distinct in that it has not parallel sides, but 2 sets of congruent sides. All right, so I wish they had a figure. Okay, hey, here's a great figure, for example, number 6. So it's a quad because it has 4 sides. 1, 2, 3, 4 sides. It's a quad. But it's not a parallelogram or in the parallelogram family because none of the sides are parallel. But it's a distinct quad because 2 sets of sides are congruent. And you can see they're marked equal. So KN and KL are marked equal. And side NM and LM are marked equal. All right. So you need to know that the diagonals are perpendicular. And if you remember what perpendicular is from Unit 1, it means it forms a 90-degree angle. And it's a kite if the opposite angles, or one pair, I should say one pair opposite angles are congruent. So let's talk about that. It's going to be L and N. K and M, the angles between the 2 congruent sides will never be equal. It'll be L and N that are equal to each other. Okay, so let's see what we got here in example number 6. All right, so we got a kite. We want to find the measure of angle N, which is the same thing as measure of angle L. Okay. So you solve our equation. So it looks like they're going to add up all 4 angles instead of equal to 360. And this is what we did at the beginning of the unit in lesson 7.1, because we know it's a polygon that has 4 sides. 4 angles add up to be 360. All right, so let's do this. All right, so angle K is 71 plus angle L, which they replace with angle N because it's the same thing. They are congruent. They replace angle M with the 52, and they keep angle N because that is what you're solving for. All right, well, they say, well, if I've got 2 angle N's, I can say 2 angle N's plus 71 plus 52 are like terms. So you need to add those together to get 123 equals 360. All right, so I'm going to subtract 123 to the other side. and twice the measure of angle N. I love how they messed this up for you guys. 237. And then divide by 2 is 118.5. So it looks like the measure of angle N is 118.5, which is also the measure of angle L, 118.5. If you want a way to check this, ladies and gentlemen, substitute N for N, 118.5, the same thing for angle L, add them together to make sure you get 360. If you do, you did this right. If you do not get 360, something's wrong. Go back and try and figure out what you did wrong. All right, the check. All right, I'm at the bottom of page 449 on your workbook, and they want me to find the measure of angle F, which happens to be the measure of angle H. Now, I notice it's marked congruent. GF and GH are marked equal, but visually it looks like GH is a little bit shorter. I don't know if that's necessarily true, but they're marked equal, so I'm going to say it's a kite because they say it's a kite. That means angle F and angle H are the same. All right, so we are going to add 128 plus X, I'll call that angle H, plus 72 plus X again for angle F because I don't know what it is, but I do know that it adds up to be 360. Like terms, X plus X is 2X. Like terms, 128 plus 72 is 200, and that equals 360. I'm going to subtract 200 to the other side. So 360 minus 200 is 160. 360 minus 200 is 160. All right, the opposite of multiplying by 2 is to divide by 2. 160 divided by 2 is 80 degrees. So it looks like angle F is 80 and angle H is 80. And again, if you want to check your work, add all four to equal 360. If it does, you're in business. If it does not, you made some kind of mistake. So 128 plus 80 plus 72 plus 80, and that does equal 360, so we did it correctly. Fantastic. All right, looks like I am moving on to example number 7. I'm on page 450 of your workbook, and it says it's a kite. I got to find AD. Well, whatever AD is, CD is, because they are marked equal. All right, and it says the diagonals of a kite are perpendicular. What that means to you is that these four angles where E is, the intersection, are all 90-degree angles. And what that means is that this triangle, AED, is a right triangle. And you happen to have side AE is 12 and side ED is 24. Yes, ladies and gentlemen, that is a Pythagorean theorem. A squared plus B squared equals C squared. And you are looking for the side across from the angle E, which is 90. We call that the hypotenuse. So you're solving for C. All right, so it's going to be AE squared. That's going to be 12 squared is 140. Okay, they want me to actually put it in. All right, I can do that. 12 to the second power. Boop. Plus 24 to the second power. Boop. Equals, and that is AD squared, which is your hypotenuse. Remember, we call that C. All right, 12 squared is 144. 24 squared is 576. And that equals C squared. You want to combine those like terms, which is 720 equals C squared, or in this case, AD squared. The opposite of squaring is the square root, 720. And when you square root 720, you break it down to 144 times 5. The square root of 144 is 12. And the 5 does not square root, so it's going to be 12 square root of 5. All right, there you go. AD is 12 square root of 5. That means CD is the same. All right, looks like we got to find the perimeter, part B. Find the perimeter of kite ABCD. All right, well, let's see what we got here. AD is 12 square root of 5. CD is 12 square root of 5. But unfortunately, we don't have AB and we don't have CB. But once we find one, we've got the other because they are marked equal. They're equal on a kite. So it looks like I'm going to do another Pythagorean theorem with the 6 and the 12 to find what AB is. Or I can do the 6 and the 12 to find what BC is. It's the same. All right, Pythagorean theorem. So it's going to be 6 squared. $12 squared. All right, 6 squared is 36. 12 squared is 144. Add those together, you get 180. And the square root of 180 is 6 square root of 5. Now, don't forget, that is both AB and CB because they are equal. So we have 12 square root of 5 plus 12 square root of 5 plus 6 square root of 5 plus 6 square root of 5. And for those of you who have not had Algebra 2, these are like terms when they are the same square root. Square root of 5 is what I mean. It's kind of like, hey, you've got 12x plus 6x. Same kind of concept. All right, so we are going to add all of those together. 6 plus 6 plus 12 is 36. And the square root of 5 just goes along for the ride. All right, there you guys go. The perimeter is 36 square root of 5. Oh, we've got to check. Bottom of the page. All right, let's see what we got here. All right, we got a kite. That means that BC and DC are equal. We've got BA and DA are equal, and we've got to find CD. We're going to do a Pythagorean theorem, ladies and gentlemen, and we're going to use the 8 and the 5 to do it because this is a 5 from B to T. That means DT is a 5. All right, so 8 squared plus 5 squared. Remember, these are right angles where T intersects. That means that CD is a hypotenuse. All right, so I'm loving that they actually left me room for this. Let's do it. 8 squared plus 5 squared equals C squared. All right, 8 squared is 64. 5 squared, 25. And that equals C squared. Let's add 64 plus 25 together, and that's going to give us 89. Hey, don't forget, the opposite of squaring is to square root. So we need to have the square root of 89, and that's going to equal C. All right, square root of 89. I'm looking for numbers that multiply to get 89. One of them needs to be a square rootable number. Numbers that get 89. One of them is square rootable. I'm not coming up with anything. So it looks to me like it is going to be the square root of 89. Now, if you must have that as a decimal, it's going to be like 9.4. So 9.4. But it doesn't break down as a radical. All right, so I've got the square root of 89. Ha! Put it all in for me. Love it. All right, perimeter of ABCD. Okay. Well, listen, I don't have BA either or DA, so I've got to do another Pythagorean theorem and then add all 4 sides together. All right, let's do it. I need to move this over. All right, so it'd be 5 and 12 because I can't move it over. So 5 and 12, Pythagorean theorem. It's 5 squared. Oh, get back over there. 5 squared plus 12 squared equals C squared. right, 5 squared is 25. 12 squared is 144. That equals c squared. All right, we're going to add 25 and 144 together. And that gives me 169. That equals c squared. And the opposite of squaring is to square root. So we need to take the square root of 169. And I believe that's 13, right? Yeah, 13. Nice. So it looks like the square root of 169 is 13. So what you guys just found is the hypotenuse BA, which is also DA. All right, so we've got all four sides. Now, don't forget, we got to find the perimeter, so we're really not done. I need to go back in here and add in all four sides. So I got to add up the square root of 89 plus the other square root of 89 plus 13 plus 13. Well, I got two square roots of 89. That's going to look weird if you haven't had algebra 2. It is going to look a little odd, but stay with me. 13 plus 13 is 26. And this is going to be your perimeter. And again, I know it's going to be an odd looking thing because they are not considered like terms. And like I said earlier, that square root of 89 is almost like an X. You're done. This is it. This is the answer. Ugly, but this is correct. If you've had algebra 2, partner up with someone or help someone out who has not had algebra 2, because they're going to look at this and go, "You can do that." And if you're a teacher who is, a brand new geometry teacher and you've never taught algebra 2, you're going to have students that are going to look at that and go, "What is this? Can that happen?" And absolutely, it can happen. All right, there you go. I'm going to hit accept because I am done. All right, you guys, if you need another example, there is one online. Your teacher can share that with you if they choose to. And it looks like I'm done because what is up next is the practice. All right, holler at me if you have any questions or anything, you guys. I'm happy to help. Ask your teacher. That is what they are there for. All right, you guys have a great day.